Hello guys, in this lesson we will continue with the free body diagram of the wheel models, okay? And so we can create a title in here, free body diagram. And so in the wheel model we have the solid structure parameters, such as if we have the assume that the wheel is in the real life solid structure application, and so we have the some kind of picture related to the wheel dynamics or the real representation, okay? And so this is our wheel. It's not a full circular because of me, but you can consider it is a perfect circular shape, okay? And so if we have this kind of wheels, we need to learn, or we need to select in the first place to what? We need to select the input variable to this station, and so the output variable should be selected in order to create a system dynamic model, okay? And so assume that the wheel is given by this shape, and so if it's a circular shape, and so what kind of input variable is applied on this wheel? And so in our case we can write it down as the torque can be applied on the system, okay? And so if we apply the torque value to this wheel, and then this wheel is a rotate, okay? And so if we create a dynamic model, and so we need to use the specific dummy variable in order to create a direction of these things, such as the x in here, okay? And so if we apply the torque value to this on the system, and then this is rotate, and so the x or position of this wheel is increased. But if we rotate this kind of system, and so we need to write it down as the theta value in order to represent how much degree is changed by under the applied this torque value, okay? And so if we have this kind of input variable, and so how can the wheel react due to this kind of torque value in this system? And so we need to write as the r is the radius of this wheel, and so if we apply the torque value on this system, and then this system creates a force value by or with the direction of these things, this such as it's equal to F. F is the friction, okay? And so if we have such kind of friction in here, and so this wheel is moving at the right hand side, okay, at the right direction, okay? Because if there is no friction in here, and so the x does not change in time, the only theta value is changed with time, okay? And so what about this? If we have such kind of wheel in here, and so we have another kind of force variable in here, like this one, m times g. M is the mass of this wheel, and g is the gravity of the earth, and so this force is applied on this kind of systems. And so This is our complete free body diagram, because if we have the input variable in here, torque, like this one, the output variable is given by the x, theta, and so ff, and so m times g value. Okay, because this comes from, or the output variable comes from the system itself, but the input variable is only applied from the outside. Okay, and so if we need to control this wheel dynamics, and so we need to control the torque value, or we need to apply the torque value on this wheel techniques. Okay, and so what about this? This is the free body diagram of our study. And so select what kind of dynamics is included in the model, which means that which dynamics is utilized on this study. And so we need to select these things, and so dynamics is given in here, and so this shape is copied in here. And then there is one dynamics is given in here, which means that it's the mechanical dynamics. And so in the improved models, this friction factor gives us a heat dynamics. Okay, or if we have any wind characteristics in here, like this one, and so this is also a friction factor, and so we need to include the fluid dynamics in here. Okay, and so if we create the torque comes from the electrical generator or the electrical motor, like the DC motor or AC motor or step motor in here, and so we need to include the electrical dynamics to these modeling techniques. Okay, but in order to simplify our model, these three dynamic are removed. Okay, because if we add this dynamic, and so this is much more complex than the normal one. Okay, and so if we improve our modeling techniques, and so we need to implement the heat, fluid, and electrical dynamics on this kind of system. But in normal form, or in the simple form, we should follow the mechanical dynamics, such as the Newton rules. Okay, this is our main course of these things. And so if the Newton rules is applied on these things, and then we need to utilize the what? F is equal to m times x dot dot. And so if we have the rotational motion in here, and so we need to add the torque value. Torque is equal to inertia times theta dot dot. Okay, and so this is coming from the what? If we rotate, or if we apply the torque value on this kind of system, and so we have the both motion types in here, such as the x is a directional, and so this is directly related to what? Translational motion. Okay, and so this comes from the rotation of this wheel, and so the rotational motion should also be considered in this study in order to solve the dynamics of these things. Okay, and so we have three answers. To choose the free body diagram is created, the selection of the dynamics is included in our model, and so the choosing the proper motion parameter is determined. Okay, and so we need to create we need to build the mathematical equation or in the analogy techniques, the equation of motion should be established by using these variables. In the next lesson, we will talk about it.